Hello everybody, we start with the next chapter in physics, that is chapter number 6, standard 10th, spectrum. So up till now you have seen in the two chapters of light the refraction of light which takes place when it passes through a plane surface or a prism, and secondly what we saw was about the refraction through lenses. Now we will see that how does a polychromatic light, that means a light which is made up of multiple colors, how would that deviate, or how will be the deviation of each and every color which is present in that particular light, and accordingly what is the end result what we get due to the deviation, different deviation of the light. And yes, we know very well that what we get will be the 7 colors getting split into the band of the colors, which is nothing but the spectrum. So first thing is about deviation. So deviation produced by a triangular prism, we very well know about the deviation which is produced by triangular prism. So if I have got a triangular prism, in this triangular prism, if this is the incident ray which was in this particular direction, and accordingly what will happen, that because of the normal over here, it is going from a rarer medium to denser medium. So rarer to denser, it is going to go towards the normal, so it is going to go towards the normal like this, and then it reaches this point where it needs to go away from the normal. So instead of going this way, it is going to go away from the normal. Accordingly, if you bring this backwards, you will find that this over here is the deviation which is produced by this particular prism ABC. Now over here, this is the first angle of deviation. The angle of deviation over here is, instead of going this is going this way, so it is delta 1, and over here the angle of deviation, because it is going to be vertically opposite angles, so that's why we know that this is the angle of deviation, that is delta 2. So again it will be this part which will be delta 2. So delta 1 and delta 2 are seen over here, and accordingly we see that delta 1 plus delta 2 is going to be delta. So we have delta 1 plus delta 2 is equals to delta, which is by the exterior angle property of the triangle. You can see by the exterior angle property of the triangle, this is what we are going to get over here as the deviation. So and this is going like this. One sec. Yeah, fine. This we already studied in the earlier part of the chapter. That was we had done this on in the part of the prism. So when we learned the part of the prism, at that time we got this thing, that how we got the delta 1 and delta 2. So that was already learned by us. So now we see further, and that is, figure shows the deviation produced by the triangular prism when a light ray PQ of a single colored enters the triangular prism ABC. It gets deviated, say, by an angle delta 1 towards the BC at the first surface AB. So at the first surface AB, it is getting deviated by delta 1, and travels towards QR, which is inside the prism. So they are given over here that this is P, this is Q, this is R, and this is S. So these are the ways it is moving. Accordingly, the QR gets further deviated, say by an angle delta 2 towards the base BC, travels straight to as RS outside the prism. So the angle of deviation delta 2 depends on the angle of inclination at the second surface, which depends on the angle of the prism. So, and the refractive index of the air with respect to glass for emergent ray RS, the total deviation delta with respect to the PQ is given by the emergent ray and this one. So that is delta over here, which means delta is equal to delta 1 plus delta 2. So this is not here, it is here. Okay, so this is the part. So delta is equals to delta 1 plus delta 2 over here. So total angle of deviation thus depends on the following three factors: angle of incidence I at the first surface, the angle of incidence over here. Secondly, the angle of prism A, that is the angle of prism over here. See, angle of incidence, we said that it was in a Nike ka sign, if you remember. The curve was like this, and this was delta minimum. So this is the same thing what is seeing over here. The angle of the prism, and finally the refractive index of the material of the prism, but the refractive index depends on the color or wavelength lambda of the light used. So the angle of deviation depends also on the color or the wavelength of the incident light. So in chapter 4 we had discussed the dependence of angle of deviation of the angle of prism, incidence, angle of prism and refractive index of the material of the prism. Here we shall discuss in detail how the deviation produced by the prism depends on the color or wavelength, that is lambda of the incident light. So we are very well aware about this part and this angle over here. Now what we are going to see is the one which is color or wavelength of the light. So color and the wavelength, that is lambda. How is the angle of deviation dependent upon the color or the wavelength of the light? So that is what we are going to see now. So dependence of deviation on color or wavelength of light. The light of different colors have same speed in air but different speed in medium. We very well know that light travels at the speed of 3 into 10⁸ meter per second in air or in vacuum. But if the medium is not air or vacuum but it is something else, then it is going to travel at different speeds. So different colors are going to travel at different speeds when they are going to travel in different mediums. So that's the main reason why there is a spectrum formed. So if the light entering the prism is not a single color, it is a mixture of several colors, then the emergent beam also has different colors arranged in a finite order. It is because of the speed of the light in transparent medium decreases with the decrease in the wavelength of light. Therefore, the refractive index of glass, the prism, metal of the prism, increases with the decrease in the wavelength of light. Therefore, the deviation caused by the prism also increases with the decrease in the wavelength. So we can see over here that what is written is, if the speed of the transparent light, if the speed of the light in the transparent medium decreases, so what is going to happen is that the speed will be dependent on the wavelength. Okay, this is also by the formula V is equals to F lambda. Now over here we see that if the lambda over here, this lambda is going to be different, automatically the velocity could be different. Considering this fact, we see that the speed of light in transparent medium decreases with the decrease in the wavelength of the light. So if the wavelength decreases, speed also decreases if frequency remains the same. So if wavelength decreases, speed also decreases. Therefore, the refractive index of the glass, that is the material of the prism, the refractive index of the glass increases with the decrease in the wavelength of light. That means with the decrease in wavelength of light, there will be decrease in the speed. With the decrease in the wavelength of the light, there will be decrease in the speed, and accordingly, due to decrease in the wavelength, there will be increase in the refractive index. That means the deviation will increase. If the refractive index increases, that means the deviation also increases. So accordingly, we see that therefore the deviation caused by the prism also increases with the decrease in the wavelength. So we can see over here, with the decrease, if the wavelength is going to decrease, then the deviation also decreases. So decrease in the wavelengths, increases. Okay, I'll write down each and every step one by one. Deviation, the wavelength decreases, accordingly velocity decreases. Velocity decreases, accordingly the refractive index R is going to increase. So if the wavelength velocity decreases, there will be a subsequent increase in the deviation. So accordingly, with the decrease in the lambda, that is decrease in the wavelength, there is a increase in the deviation. Understood? Decrease in wavelength causes increase in the deviation. If In visible light, violet color, that is lambda 4000 angstrom, is deviated the most, and the red color, wavelength 8000 angstrom, is deviated the least. Because in glass, the speed of violet light is least and that of red light is most. So we can see that violet has got 4000 angstrom, whereas red has got 8000 angstrom as the lambda. Okay, so accordingly what will happen? This is less, so accordingly deviation is more. This is more, so the deviation is less. Got it? This is a simple understanding. Okay. Now, colors in the white light and the frequencies, wavelength and frequency. The white light emitted from the source consists of light of different wavelengths. The light of the different wavelengths produce the sensation of different colors on the retina of our eye. So we perceive them as different colors. The prominent colors in white light are violet, indigo, blue, green, yellow, orange, red. Different colors differ in their wavelength. In fact, wavelength is the characteristics of color irrespective of its origin. So wavelength becomes the characteristics of that particular color irrespective of this origin, whether it is originated from what particular source of the light, but the wavelength becomes a characteristic property of that. That's why when we say 4000, we know that it is violet, and when we say 8000, it will be red. So accordingly, there is a complete range given to the different colors over here. So the light of the same color obtained from different sources will have the same wavelength. In other words, color is a subjective property of the light related to its wavelength. So we can see that even if the sources are different, but if the color of the light which is produced by that particular source is the same, then it is found that the wavelength of that particular color light will be same. So whether, like for example, if I say a blue colored flame is, we can get a blue color flame when we burn hydrogen, or we can have blue color flame when we are burning, let's say, methane. In both these cases, the blue color is going to be there. You will find that both the blue colors, what we see, they will have the same wavelength. The wavelength of blue color from one and the wavelength by blue color of second one, both of them will be of the same wavelength. That means wavelength hence becomes the characteristic property, which is a subjective property of that particular light. So if I say blue color, I know that it is, can be easily say that okay, blue color na यानी ये particular kind of, ये particular wavelength का light. So if the wavelength of light is something in a particular thing like 5000, then you know that it is a blue colored light. The table below gives the range of the wavelength and the frequency of the light of different colors. So we have the violet is 4000 to 4460. That is the frequency in the range of 7.5 to 6.73. Indigo is 4463 to 4640. Blue is 4640 to 5000. Green 5000 to 5780, yellow 5780 to 5920, orange 5920 to 6200, and red 6200 to 8000. And frequency accordingly will be 7.5 to 6.73, 6.73 to 6.47, 6.47 to 6.01, 6.01 to 5.19, 5.19 to 5.07, 5.07 to 4.84, and 4.84 to 3.75. These are the different wavelengths and the frequencies of the different colors of the light. You need not learn this table by heart. It's not required. It is not required to learn this by heart. You should only know the range, that is 4000 to 8000. 4000 will be for the violet color and 8000 will be red. Note in the above table, the letter Armstrong denotes the unit Armstrong. The A denotes Armstrong, where 1 Armstrong is equals to 10 raised to 1 Armstrong is equals to 10 raised to minus 9 meters. So 1 Armstrong is 10 raised to minus 10. Sorry, it's minus 10 meters. 1 raised to 10 raised to minus 10 meters. Sorry, 9 was nano. Nowadays, the wavelength is expressed mostly in nanometers. So Armstrong is not used. We use it as nanometers. So it is 10 to 1 nanometer is 10 to minus 9 meters. In the spectrum of white light, the red color has the longest wavelength 8000, or lowest frequency 3.75 into 10 is to 14, and the violet color has the shortest wavelength 4000, and the highest frequency 7.5 into 10 raised to 14. So you will always find that when you multiply both these frequency and the wavelength, you will find that the answer to that will be 3 into 10 is to 8 meters square. Okay, you can see this. Like they are given us that for red color is they given the red color to be as okay, I'll take the violet color, we'll say. So violet is 4000 Armstrong, which is 4 into 10 raised to minus 10 meters, and it has got this is the wavelength. So wavelength is equals to 4 into 10 raised to minus 10 meters, and the frequency is given as 3.75. No, sorry, frequency is 7.5 into 10 raised to 14 hertz. So hertz is nothing but 1 upon second, right? So we multiply this thing, it is nothing but 4 into 7.5 into 10 raised to minus 10 into 10 raised to 14. So that will be 7.5 into 4 will be equal to 30 into 10 raised to minus 10 plus 14. Okay, sorry, this is minus 10, yeah, 4000, no, sorry, 4000. So that will be equal to 4 into 10 raised to 3 into 10 raised to minus 10 is equal to 4 into 10 raised to minus 7. So accordingly this is minus 7. So this is minus 7 plus, so this is 3 into 10 raised to 7, that is 3 into 10 raised to 8 meter. This is in meters, this per second, so it is meter per second. You can always cross check if in case they ask you a question and you know certain values. So if I know that the value of red is 8000 and I want to find out the wavelength of it, you can always consider this for the formula, that the speed is equals to, we know that the velocity, we know over here that velocity is equals to f lambda into f. So v is equal to f lambda is the formula. So v is equals to 3 into 10 raised to 8 meter per second is going to be standard. So whenever you need to do any calculations, normally not asked. I'm telling you once again, normally not asked, but in case they ask you and you have certain values in mind, then you can always find the if you want to have the frequency, you can find out the wavelength. If you have the wavelength, you can find out the frequency. Fine. So now we see the dispersion. So the next thing what we are having is the dispersion of the light. So Isaac Newton, while studying the image of the heavenly bodies formed due to the refraction of white light by a lens, found that the image of image is colored at its edges. He thought that the colored image is due to some defect of the lens. He then repeated the experiment with a carefully polished lens, but the image was still colored. Newton then concluded that the fault is not with the lens, but there is something in the nature of white light itself due to which the image is colored at its edges. To investigate it further, he performed another experiment with a prism. So Newton allowed white light. So what he did was a simple experiment. So he took a prism. He took a prism over here and he used a screen here. He allowed a white light. So that is the white light, that is a light of the of a normal sunlight. He took some white light that is polychromatic. So he put white light through the prism and he found that this got into like this, and he could get the color over here, that red to violet. So violet, indigo, blue, green, yellow, orange, red was violet, indigo, blue, green, yellow, orange and red is what he saw on the screen. So this is what he got from the experiment. So Newton allowed the light from sun to enter a dark room through a small aperture in the window and placed a glass prism in the path of the light ray. The light entering out of the prism was received on a white screen. On the screen, a colored patch like a rainbow, as shown in the figure, was obtained, which was termed as spectrum. So spectrum is nothing but this particular band of colors. What you get over here is called as the spectrum. Starting from the side of the base of the prism, the order of the colors in the spectrum are on screen is violet, indigo, blue, green, yellow, orange and red. This order of color in the spectrum are easily being remembered by the word Vibgyor. Conclusion: from the above experiment, Newton concluded that white light consists of 7 prominent colors. Each color corresponds to a small range of wavelength. Thus, white light is a mixture of large number of wavelengths. That is, it is polychromatic in nature. So, Newton just discovered that the white light was actually not just white, but it was a combination of 7 different colors, 7 prominent different colors, which were violet, indigo, blue, green, yellow, orange and red. Note, in the spectrum, each color is mixed with the other color. There is no sharp boundary line separating the color. In diagram, colors are shown widely separated just for clarity. So over here they are widely separated. That oh ये pure, ये violet, ये indigo, ये blue. ऐसा दिखा है, but actually they are not like. You can see when you see a rainbow. Do you see a line that okay ये पूरा का पूरा एक line? फिर second no, they all merge together. The colors get merged together. So when they merge together, so always there is a you can see the red color or orange color के बीच में कोई separating line नहीं है. It is like merging with the red and orange, and then orange and the yellow gets merged together, then yellow and green gets merged together. So accordingly, you will always feel the band to be a complete band of multicolor with this forming not in separate bands, separate layers, but a mixed one. So each color corresponds to a small range of so in the diagram are shown widely separated just for clarity. The total spread of color is much less than shown in the diagram. Different colors have different width on the screen. Now dispersion. So we have the definition of dispersion. The phenomena of splitting of white light by a prism into its constituent colors is known as prism, or known as dispersion. So what is dispersion? This particular phenomena of splitting the white light into its constituent colors is called as dispersion. So the phenomena of splitting of white light by a prism, phenomena of splitting of the white light by a prism into its constituent colors is known as dispersion. Accordingly, then we have the spectrum. So what is the spectrum? On passing white light through a prism, a band of colors seen on a screen is called as the spectrum. So the band of colors seen on the thing is called as the spectrum. Now let us understand what is the main cause of this spectrum. So let's see the cause of the spectrum. The cause of dispersion of white light is the change in speed of light with wavelengths. When white color enters the surface of the light prism, light of different colors due to their different speed in glass gets deviated through different angles towards the base of the prism. So you can see that when the white light enters into this thing, then because each and every color has got different wavelengths, and hence due to the difference in the wavelength, there is a difference in the deviation. Okay, lesser the wavelength, more the deviation. Accordingly, jiska wavelength, the violet has got the least amount of wavelength, and hence it is going to be deviated the most. So that's why due to the difference in the wavelengths, there will be a difference in the deviation. The difference in the deviation causes each and every color to split from each other. So the dispersion or splitting of white light into its constituent color takes place at the first surface of the prism. The violet color is deviated the most, while the red color is deviated the least. Therefore, light of different colors present in the white light follows different path inside the glass prism and then strikes the second surface of the prism. So first, it is getting deviated here itself. The dispersion takes place at this point. At this point when it reaches, it's already deviated. So here what is going to take place is separation to already ho chuka hai. Only thing here, the refraction is going to take place. So the dispersion always takes place on the first surface of the prism. The second surface, there is no dispersion taking place. On the second surface of the prism, only refraction takes place from glass to air, and the different colors are deviated through different angles. That is, violet is deviated most and red the least. As a result, the color gets further separated on refraction at the second surface. The light emerging out of the prism thus have different colors that spread out to form a spectrum on the screen. So here you see that firstly they are getting deviated, they are getting dispersed. The dispersion takes place because of this particular medium, this particular surface. Why is that taking place? Because of the change in the wavelength of the different colors. Different wavelengths get differently deviated. The difference in deviation causes splitting of the color. When it reaches this point, at this point, there is further refraction. And due to the further refraction, ये सिर्फ ज़्यादा दूर जाएंगे एक दूसरे से. So there will be much more wider part. That's the only thing. So what happens in the second surface is only refraction takes place, which is just emerging out to be a bigger band of colors, or the spectrum gets wider when it is passing through the second part. So the light emitting out of the prism does have different colors that spread out to form a spectrum of color screen. Note, dispersion of violet occurs only at the first surface of the prism. Dispersion always occurs only at the first surface of the prism. Deviation of light occurs at both the surface of the prism. The deviation would take place here also and here also. Due to the deviation here, the colors got separated. So that's why deviation did happen here. Here also deviation takes place, and that is why they are getting separated much more. And the prism does not produce colors, but it only splits the various colors present in the light incident on it. So there is nothing like this prism is generating the colors. No, the prism does not generate any colors. It is just splitting the various colors which are present in that particular light. So that's why we see that this prism is not going to generate any color. So if it is not a white light, but only one single colored light, it is not going to form any kind of different colors. It will just be a single kind of a ray of light. So that was the first part of the chapter. So that was about the spectrum, and now we will see in the next video the electromagnetic spectrum and its broad classifications.